Okay, so let's talk first about the circle inside the 2 by 2 by 2 square. So we said the circle has radius 1.
Yeah.
So what is the area of this circle?
The area is, that's going to be a pi.
Pi. And what's the area of the square?
4.
4. So the circle takes up pi divided by 4.
Which is that like 74%?
Yeah, let's see. So 3.1415 divided by 4 is about 78.5%.
Okay.
Yeah, I think they said about 79 in the movie.
It's pretty close.
Yeah, okay. So that's good. In the, I guess before we move on, we better mention the one other thing she said. She said part of the problem is the diagonal gets pretty long.
But the distance between the sides stays the same.
Yeah, so it's 1 to that side, 1 to that side, and 1 and 1. But how long is the diagonal here?
It's,
Actually, let's do half the diagonal. How long is half the diagonal? Just from here to here.
square root of 2.
Yeah.
Okay, and how do we know that?
Using the Pythagorean theorem.
Yeah, because this is a 1 by 1 triangle.
Yeah.
So 1 squared plus 1 squared is 2.
And I just happen to know that this is a right angle because this is tangent. And when you intersect a radii with a tangent, you get a right angle here.
Yeah, good. Very good. Okay, so the diagonal, or half the diagonal here, is root 2. Now let's go up to a sphere and see if we can understand what's going on inside of a box, a 2 by 2 by 2 by 2 box. And we have, I don't even know how to draw it. You know, a sphere in a box, right?
Yeah.
Okay, so if this box is 2 by 2 by 2, first of all, what's the radius of the sphere?
Still, it's 1.
Ah, why?
Because it's still tangent to each of the faces. And its center is the center of the cube.
Okay, and then what? What's
and
the
then
lesson?
You can just draw, because the line, this is 2,
and
that's the diameter. You can sort of move that over.
Good. So the diameter is 2, so the radius is 1. Do you see that?
Yeah.
Okay, and so what's the volume of a sphere? Does anybody know?
Isn't it like pi r cubed?
I think it's 4/3 pi r cubed.
Yeah, it has a slightly different formula. 4/3 pi r cubed. In fact, the volume of spheres in odd dimensions, the formula is a little bit complicated, and it's lucky they mentioned 30 dimensions because in even dimensions the formula is actually pretty easy. What's the volume of the box? So the radius is 1, so the volume of the sphere is 4/3 pi. What's the volume of the box?
It's 8.
8, yeah. So what's the fraction we need to compute to know the portion of the distance here?
4/3 pi over 2.
No, what's the volume of the box?
It's 8.
Okay, so 4/3 pi
Over 8.
Yeah, which becomes, how does that fraction simplify?
It's 3/4 pi times 8. Wouldn't it be 6 pi? Oh, no.
Well, I'm taking 4/3 pi
Yeah.
and chopping it up into how many pieces?
8 pieces.
8 pieces. So, like, what is 1/3 divided by 8? What do I get when I chop 1/3 into 8 pieces?
1/24.
Okay, so what do you think I get when I chop 4/3 pi into 8 pieces?
4/24 pi?
Yeah. 4 pi over 24. Which does simplify a little bit.
It's pi over 6.
Pi over 6. Okay. So we can just type in 3.14 divided by 6, and we get
52%.
Okay, so there's the calculations. A little bit of fraction division here, but there's where we get the numbers. Now let's look at the diagonal, and then the diagonal as we go up in the next video. Okay.
All right.